Now let's take a moment and look at transistor AC input impedance. Now you remember that we looked briefly a while ago at the transistor DC impedance. And most of the time we can ignore the DC impedance. Remember what that was? That's the impedance that we see looking into here, Z in. And we said that the input impedance over here was equal to approximately beta times whatever was in this path. So Z in was approximately equal to beta RE. Now it was understood as you're doing this analysis that this beta was beta DC. Oftentimes we don't put this subscript in here. We just assume that by looking at the circuit and the context that we mean beta DC. And sometimes textbooks and data sheets don't use beta DC, they use HFE. And so it's going to be H, small h, capital F, capital E, times RE. So that gives us the input impedance, and oftentimes it's quite high enough that we can, in most cases of analyzing circuits, ignore it. When we take a look at AC, something similar happens. And one of the peculiar things that happens is that right at that, inside this junction, inside of here, is an intrinsic dynamic impedance. Inside of it called RE prime. It does not show up in DC circuit analysis, but it does show up in AC circuit analysis. And RE prime is equal to 25 millivolts divided by IE. Now this is a very interesting parameter because this is an AC resistance, but this is a DC current. So the AC resistance is dependent upon the DC current flowing through this base emitter junction. When we look at the circuit, at the input from the base, Zn, now looking at it from the AC standpoint, and oftentimes we won't put in AC, we'll just assume that the context tells us that, we find something very similar to this expression over here. And that is that we may have some sort of AC resistance here. And to denote AC, we use a small letter R and a big letter E to remind us that it's in the emitter. And now Zn is approximately equal to beta AC. And oftentimes the AC is not shown, but the context will tell us whether it's beta AC or DC, times RE prime, the intrinsic AC impedance inside the diode, plus whatever AC impedance there is in the emitter path, RE. Or you'll see it in the literature as small h rather, and a small FE. So we know that that's AC as opposed to here it's DC, times RE prime plus RE. Now, in the case of AC analysis, we pretty well always have to take this into account. But in DC analysis, generally the number is high enough that we can ignore it.